Inclined plane, basically you're overcoming a large resistance by relative force, but you're doing it over a distance. That's the function of an inclined plane. All right? All right, let's take a look at A-frame. This is what's known as an A-frame. It says it's carrying a 2,000-pound load. Find the forces acting on all the joints. So I want you to find me everything. I want to know AX, AY. I want to know BX, BY. I want to know CX, CY. I want to know EX, EY. Those are all pins, by the way. I want to know GX, GY, and so forth. Okay? Now, step number 1 says, if possible, go ahead and calculate support reactions. Is it possible here? Yeah. Because I can cut through here, cut through there, and back. This is just a roller. I know there's 3 of them. It doesn't matter how many you put in there. So this will be free body diagram, entire frame. What I need to put in here is AY, AX, HY. That's it. That's the free body diagram of the entire frame. Notice the pins at B, C, and E did not touch. I didn't touch them. So they are internal right now. This is the cable that extends to 2,000. All right, write me the equations for this. Easy. Sum forces in the X equals 0, positive to the right. AX equals 0. I'm going to do a sum moments because I know, Nora's told me, if you want an answer, usually do a moment. So I'm going to do a moment. I'm going to do it at A. I'm going to take counterclockwise positive. Taking a moment at A eliminates these guys right here. I've got HY times its distance. The distance from here to here is 10. And this is creating a counterclockwise about A, so that's a plus. 2,000 times its distance, and this is creating a clockwise, so that's negative. What's the distance from the 2,000 to A? Huh? I heard 16. I heard 19. The beauty of this side of campus is there's only one right answer. It's not pink today, blue tomorrow, and I feel it's 16 today. I'm thinking it might be 19. No. Unacceptable. Okay? The answer is it's 19, and it's done cleverly to make you think it's 16, but it's 10 plus 6 is 16. Plus the radius of this disc is 3, that's 19. So be careful, pay attention to details. Details will get you in a mess if you don't pay attention to it. That's equal to 0. So HY is equal to a positive 3,800. That means my guess of upwards is correct. Fantastic. Now, all I have to do is do a sum forces Y. Could I do a moment? Sure. I'm going to do a moment just to be different. I'm going to take a moment at H. And I'm going to say clockwise positive. Just to be different. 10 times AY plus 2,000 times 9, 6 plus the 3, equals 0. Or AY is equal to minus 1800. Or AY is equal to 1800 downward. Guessed wrong. I guessed wrong. Am I always going to guess right? No, neither are you. But if you think about it a little bit, here's this frame, right? And I'm basically putting all the weight over here. This thing is going to try to take it this way, correct? If it's going to tilt and rotate, it's going to rotate this way. What does this pin got to do to stop that rotation? Push downward to keep it right there. So it makes sense that it is a negative when I drew it upward. All right, that said, now step 2 says, hey, dismember this thing into its pieces. So I'm going to take and unscrew this pin here, and I'm going to have a free body diagram pulley. And it's going to look like this. I know it's 2000. I know this is 2000. This would have a pin reaction GX here and a pin reaction GY there. How is that member pulley attached to BE? By a pin. Okay, so that pin has got to exert a force on the pulley. I'm calling it GX and GY.
With you.
Some forces in the X equals 0, positive to the right. GX is equal to 2000. Or GX minus 2000 equals 0. GX equals 2000. Some forces in the Y equals 0, positive up. That just says GY equals 2000. Or GY upward minus 2000 equals 0, GY equals 2000. Okay, next, I'm going to draw a free body diagram of this horizontal piece. Free body diagram, BEG. I know I have GX and a GY. 2000, 2000. I know that for a fact. I calculated them already. They're calculated right there. And by Newton's third law, they have to be equal and opposite. So if GY was up in here, it's got to be downward. If GY is to the right, it's got to be to the left. Got it? Next, I'm going to draw at E, pin reaction EY, EX. Because I took this pin out over here. There's a pin right there. I took it out, so I got to show an EX, EY. I took out a pin here. I got to show a BX, BY. Again, these directions right here, completely arbitrary. If I chose the right direction, I'm going to get a positive answer. If I chose the wrong direction, I'm going to get a negative. Agreed? Now, once you have drawn the diagrams, the free body diagrams, and you've chosen on EX and EY, BX, BY, etc., you never ever change it. Never touch the free body diagram. If there's a negative, you carry the negative with you. Okay? If I want an answer right away, what should I do? Do a moment. Best thing to do is either a moment at B or a moment at E. Correct? Let's say I take a moment at B. BY, BX, EX, GX all wipe out, and I'll get EY and GY. Perfect. That gives me an answer. Some moments at B equals 0, counterclockwise positive. EY times 6 minus 2,000 times 12 equals 0. EY is equal to 4,000, and it is a positive, so it is upwards. 4,000 pounds upwards. Fantastic. I'm going to flip this, and I'm going to say, hey, let's do a moment at E equals 0. Counterclockwise positive. So now, EX, EY go out, GX goes out, and BX goes out. Notice what's left? BY and GY. Perfect. 6 times BY minus 2,000 times 6 equals 0. BY is 2,000. I got a positive. I'm batting pretty good right now because I got all positives, so that means my BY and EY directions are correct. Last but not least, some forces in the X equals 0, positive to the right. BX plus EX minus 2,000 equals 0, or BX plus EX equals 2,000. Ah, crap, I didn't get an answer. Yeah, why didn't you get an answer? That's the question you should ask. Why didn't I get an answer? It's not because I didn't write a moment equation. Why didn't I get an answer? How many unknowns were there? 4. There's no freaking way I'm going to get an answer for every single support reaction there, because there's 4 of them. If there was 3, that equation would have given me an answer, but there's 4. So it's to be expected that you will get an equation instead of a value. There's the equation. That's okay. Because maybe I can go to a different free body diagram, get a B or an E, and bring it back. That's why in the plan of attack it says you may have to work back and forth between members. All right? Next, I'm going to draw this sucker. So I'm going to draw free body diagram C, E, H. I'm going to have a HY, 3,800. I'm going to have a EX, and I'm going to have a EY. EY I know. I already know it's coming from this value. So if you have something, carry it over. 4,000. There's the 4,000 from here. Okay. Then I have at D 2,000 coming from the pulley. And then over here I have a pin CX CY. That's the free body diagram of the vertical member. Wherever there's a pin, which on the diagram is a dot or a circle, I gotta put in a CX, CY, BX, BY, EX, EY, etc. Now, when I was in your shoes, what I did was I had colored pencils, and wherever I had a 4,000 and I brought it over, I put it in a different color. Just as a reminder to me, hey, you did not get this 4,000 from this free body diagram CEH. You got it from someplace else. So if that number had been a negative, I would have carried the negative 4,000 with me, because I don't touch the free body diagrams once they're drawn. All right. One quickie gets me an answer right away. What would be the quickie? moment at C. Moment at C, and I'm going to take clockwise positive equals 0. That's EX times 9 minus 2,000 times 6 equals 0. EX comes out 1333.33. I got a positive. Hey, I'm doing good because I got a positive answer. I guessed the right direction. But now that I have that, I can go over here and dump that into this equation, which means now BX is equal to 666.7. And that direction is correct because I got a positive answer, meaning BX is to the right. This is when the plan of attack says, hey, you may have to work back and forth between members. It's exactly what it's saying to you. I got an answer over here. I went back over here, got an answer. Now I'm coming back to the previous free body diagram to get some more answers, hopefully. Okay, if I sum forces in the X equals 0, positive this way to the left, CX plus EX minus the 2,000 equals 0, CX is equal to 666.7 or 67, whatever. Got a positive answer, so I chose the right direction. And sum forces in the Y equals 0, positive upward. This says 3,800 from HY minus the 4,000 from EY plus the CY equals 0. Or CY is equal to 200. CY equals 200. Well, guess what? You have found everything you need to find. You found AX, AY by doing a free body on the whole thing. You found HY. You found BX, BY. You found CX, CY. You found EX, EY. You found GX, GY. There's nothing left to find. You found the force in every single pin. There's one free body diagram we did not draw. What's that free body diagram? ABC, that slanted member. Right? Let's draw that just for shits and giggles. I don't have to. Here's this. What do I know? I know AY is 1,800 down. AX is 0. I know B is BX this way, which I know is 666.7. I know BY has to be upwards, and BY is 2,000. I know CX has to be to the right, and I know CX is 666.7. And I know CY is downward at 200. I don't need that. I got everything. But does it check? Do the ups equal the downs? 1,800 down, 200 down, that's 2,000 down. The BY is 2,000. The ups match the downs. How about do the lefts match the rights? Well, I got 200 here. No, I'm sorry, this is 0. I got 667 that way, I got 667 that way. Do they balance? Do the X's balance? Yeah. Do the Y's balance? Yeah. You don't need a solution manual. You don't need check, and you don't need me to tell you you did this right. It's right. Now, if I had skipped step 1, which was draw a free body diagram, whole thing, I would have needed this free body diagram in order to get everything. But because I did a free body diagram of the whole thing, I didn't need that free body diagram. Okay? Any questions on this one?